Hi everyone, for this video we're going to talk about binomial theorem expansion, how to find terms and coefficients in that expansion, how is it related to Pascal's triangle, and then we're also going to review combinations. Okay, let's recall Pascal triangle. So a Pascal triangle, it looks like this. Okay, 1 and then 1 plus 1 is 2 and then 1 again, then 1 again, 1 plus 2 is 3, 2 plus 1 is 3, and then 1. So you see the pattern, and so 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, 1, and so on and so forth. So we can call this is our row 0, row 1, row 2, row 3, row 4, row 5, and so on and so forth. These numbers here are the binomial coefficients, and we can use this later on when we do expand some binomial expansions. Now let's review combination. So for combination, we know that it is n taken r at a time, and the order does not matter. So the formula is n factorial over r factorial times n minus r factorial. So let's say we have 2 taken 0 at a time. Let's just use that. So we have 2 factorial over 0 factorial and 2 minus 0 factorial. 0 factorial is equal to 1. So this is 2 times 1 over 1 times 2 minus 0. So that's 2 factorial times 1. So the answer is 1. Now let's try 2 taken 1 at a time. Let's just write here 1. So this would be 2 factorial over 1 factorial times 2 minus 1 factorial. And this is equal to 2. Now why don't you try 2 taken 2 at a time? See what you will get. So that's 2 factorial over 2 factorial times 2 minus 2 factorial. So this is equal to 1. So as you can see and observe, we have 1 to 1. Isn't that the coefficients at row 2? 1 to 1. Now let's try row 3 and see if we'll get 1, 3, 3, 1. So why don't you pause this video and try to get 3 taken 0 at a time, 3 taken 1 at a time, 3 taken 2 at a time, and 3 taken 3 at a time. So using the combination formula, so we'll get 1, 3, 3, 1, which are the binomial coefficients in row 3. Okay, let's try to expand x minus 1 cubed. So normally we'll just do the FOIL. So this is x minus 1 times x minus 1 times x minus 1. So let's use the binomial theorem to find the answer for x minus 1 cubed. Because this is raised to the third power, so we're going to use row 3. Okay, so how we do that? So we know the coefficients of the binomial expansion is 1, 3, 3, 1. So let's start with 1 times the first term, which is x raised to the third power, times the second term, which is minus 1 raised to the 0 power, plus 3 times x raised to the second power this time, times negative 1 raised to the first power, plus 3 times x to the first power times negative 1 to the second power, and lastly times plus 1 times x to the 0 power times negative 1 raised to the third power. So as you will notice, the exponents will add up to 3. So 3 plus 0 is 3. Okay, 2 plus 1 is 3. 1 plus 2 is 3, and 0 plus 3 is 3. So as you can see, the first term of the binomial, the exponent decreases. So it's 3, 2, 1, and 0. And the second term of the binomial, the negative 1, the exponent or the index increases. So from 0, 1, 2, and 3. And of course, we use the binomial coefficients of 1, 3, 3, 1 of the Pascal's triangle. Okay, let's simplify this. So 1 times x cubed is x cubed. Negative 1 raised to the 0 power is equal to 1. So that is x cubed, plus negative 1 raised to 1 is negative 1 times x squared times 3. So that is minus 3x squared plus negative 1 times negative 1 is positive 1 times 3x plus 3x, and negative 1 cube is negative 1. This x to the 0 is 1. 1 times 1. 1 times negative 1. So minus 1. Okay, let's check this using FOIL method. So we have x minus 1 is x minus 1 times x minus 1. So let's start with this. This is x squared minus 2x plus 1. Multiply this by x minus 1. So this would be x cubed minus 2x squared plus x minus, so this is x cubed, okay, minus x squared plus 2x minus 1. Okay, let's combine similar terms. So for x cubed, it's x cubed, 2x squared, negative 2x squared, minus x squared is negative 3x squared, positive x, plus 2x is positive 3x, and minus 1. So we get the same answer.